A very good evening to one and all gathered here. Today we are going to see the next module number 4 under chapter number 2, detailed design and prototyping under the course product innovation and entrepreneurship. So let us go with the concept detailed design and prototyping. So what do you mean by the physical term detailed design and prototyping? So this process involves creating a product and conducting a performance test through several iterative stages in a sequential manner from low fidelity to high fidelity models. What is the difference between these two? Low fidelity means very simple representation of design idea which has not been completed 100% fully. Whereas high fidelity model is nothing but completely high polished final prototype according to the user needs. So detailed design and prototyping involving creation of ideas through several iterative stages. So that involves these two different types of models like low fidelity and high fidelity models. Prototyping helps the designer to visualize the product through evaluation and refine the product ideas and concepts. It also allows for testing functionality, better user experience, and getting feedback before finalizing the design and moving to the next level of production. So what is design? What is meant by detailed design? What is the purpose of the detailed design? The main primary objective is to modify by optimizing certain design factors by assigning and fixing the design details. Say, for example, if you want to improve the quality and cost of the design of a given product, you have to optimize those particular the factors as specified by the end user. Next one is what is the process involved in the detailed design? So building a prototype uh, which lays the which completely tells about the specifications of the final product, considering various factors like product packaging, materials, and manufacturing process. So this comes under the detailed design stage. What are the outcome? The detailed design ensures whether the product meets the user needs or not in terms of functionality, working principle, and the aesthetic appeal, and also technically whether it is viable or not. Next one, prototyping. The purpose of doing prototyping to test and refine whether the design concepts can be made proven through physical or digital model using customized software. What are the process involved in generating prototype? So using standard industry CAD modeling software, we can able to make a solid modeling of a proposed product idea by through serious number of iteration according to the customer feedback. So starting from idea stage to final stage of the product. So low fidelity and high fidelity design. So these are the two things which comes under the prototyping. Low fidelity means incomplete design, that is semi-partial the design work, which clearly describes the shape, size, and general features of the design. Whereas high fidelity is nothing but almost uh, nearing to the final finish of the product model, which involves color, appearance, texture, and functionality testing, etc. So what are the relationship between detailed design and prototyping? How we can able to balance a trade-off fit between these two things in product innovation? Prototyping is one of the most important step in the design process, so which provides uh, the user to test the thought process according to the creative idea, and if there is some refinement is required in the concept, so it has to be done before it is finalized. A detailed design can be built based on the lessons learned from the past through the prototype generation process, ensuring whether the final product is considered to be well-defined one or not. The iterative nature of prototyping, which improves the continuous progress in the quality of the product design, and we can able to make it more user-friendly in nature. So this is the thing which describes clearly about the product design thinking process, detailed design thinking, and the prototyping process. Next one, after performing these two functions, uh, followed by the next one is functionality and manufacturability. Once the product design prototype is ready, so we have to test the design functionality and I ensure whether it can be easily manufactured by the available raw materials or not. So these are the two interconnected the terms. So which tells about how the product can be performed to serve its the purpose. The functionality refers to the performance of the product as specified in the design of a model. Whereas manufacturability refers to how easily the product design which is given in the blueprint can be really built up more economical way by reducing all the cost wastages. So the effective design makes a proper balance fit between the two considerations. So balancing functionality and manufacturability. So these are the main important points to be noted. Design for manufacturing. So this is approach which makes the manufacturing process and the supporting constraint more easier, much better as per the input given in the CAD model. DFM aims to simplify the CAD design by using readily available materials. We can also optimize the assembly of the component by simplifying the, the manufacturing features according to the CAD design. And also we can able to reduce the cost wastage, say wastage due to production cost, labor cost, etc. by adopting a cheap manufacturing process. So what is the trade-off between these two terms? Say for an example, a more complex design may offer better performance, but it could be more difficult and expensive to manufacture if the design is very complicated and difficult to understand by the manufacturer. So the designer must be very careful uh, while constructing the idea by properly balancing both functionality of the working model as well as the manufacturability of the product design. So what is the major importance of this of these two things? A good design will give you a proper balance between functionality and manufacturability, and that lead to improvement in the design efficiency of the product. So using minimum cheap raw material, we can able to produce the product at less cost at affordable price. So this benefits both manufacturer as well as the final end users of the product. So, in nutshell, a well-designed product is one that not only serve the performance as specified in the design, at the same time you have to produce cost-effective product by using the basic available raw material, which are at cheap cost with high quality. The next one in the product innovation, next to functionality and manufacturability, is bill of materials and component supply chain. How these things are related to product innovation. First, let us understand what do you mean by a bill of material. It is a paper document which tries to support the various inventory list of raw material, components, as well as the final assembly needed to manufacture a product. So how bill of materials related to supply chain system? Say product planning. A bill of material will give you the detailed information about what are all the components to be manufactured for a product. So it allows the manufacturer to plan for the production schedule and order the materials accordingly. Next one is inventory control. Listing the required components in the shop and identify what are all the quantities required according to the inventory. So we have to propose the bill of material as per the inventory management such that more materials will not be wasted. Using minimum number of raw material, what is required, we can able to make it as a final product by optimizing the stock position in the inventory without much wastage. Next one is production planning. It's the same repetition of the information. Let us skip to the next one. So cost management, next to inventory control. So the bill of material will try to estimate the better cost of material, identify what are all the critical area where we can go for cost reduction in the manufacturing process. And supply chain optimization. Bill of material will try to have better collaboration with suppliers, material suppliers, by ensuring timely delivery of components and managing quick changes to the product throughout the process. The last one, quality control. Bill of material ensure whether the correct components are being used through the manufacturing, which contributes to product quality and continuous improvement in the manufacturing. Procurement. The bill of material information will identify whether we have done the best procurement, say purchasing, input production, that is internal production, outsourcing for each part in the manufacturing cycle. Let us take an example. Uh, Imagine a car manufacturer. Their bill of material for an automobile production would include everything, right from chassis and engine components to the smallest bolt and screws. So this list helps in ordering the raw material, knowing what are the specific raw materials for manufacturing the automobile, steel, rubber, plastics, etc. These are the basic available form of raw material for making an automobile. And next, going for a plan of production, sequencing the assembly process from chassis fabrication to final complete product assembly. Then managing the inventory, ensuring whether each have enough components to meet the required demand or not. Finally, collaborating with suppliers, working with suppliers to ensure the timely delivery of the necessary components. And in essence, bill of material is the final blueprint for the production, and it gives the most important weightage for managing the supply chain more effectively. So today we have gone through the basic importance of detailed designing and prototyping. So what is meant by functionality and manufacturability in design prototyping, then importance of bill of material and various supply chain components. So with this, I thank each and every one of you. The next meeting, we will see further the continuation in chapter number 2, the next module number 5. So thank you one and all.